Now let's talk about the fundamental counting principle. Now you've used this in the past. This is just the technical word for it. The fundamental counting principle states that if there are m ways that one event can occur, say choosing what shirt you're going to wear, and n ways that another event can occur, say choosing what pants you wear, then there are m times n ways that both events can occur. So if you multiply the number of shirts you have times the number of pants you have, that's how many different outfits or arrangements you can put together. So let's apply that on this problem right down here. So we got Mr. Benson here, and he is craving pizza right now, which I kind of am, even though it is 8:35 in the morning. Okay? He calls Papa John's, and they ask him if he wants thin crust or original crust. That's their first question. Well, I want original crust. Then they ask him if he wants white or red sauce. And I thought that was weird. Of course I want red sauce. But they ask me, they give me those two choices. And finally they ask him if he wants pepperoni, sausage, or cheese. And I was like, that's all you have for options? And they said, yep. It's like, okay, well, I'll choose sausage in this situation. The question I have, though, for you is how many different types of pizzas can Mr. Benson make? Now, in the past, what you would do is you would make something called a number tree. So, or a tree diagram for this. So you got first Mr. Benson's pizza. And Mr. Benson's pizza has two options right off the bat, thin crust or original. And from the thin crust or the original, they have two more options. We got red sauce or white, right? Red sauce or white. And even from here, we have, for red sauce or white and thin crust, we have three different options to put on there: pepperoni, sausage, or cheese. So PSC, how about this? PSC, 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 PSC. So in the end, if we count the end of this branch or end of this tree, this tells us how many different options there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different combinations of pizzas that I can make from Papa John's on this day. Now, a little easier way to do it is because these trees can get so complicated so fast because of the exponential growth. What we instead use is, I like to call them like buckets. So I got a bucket for each different option. 1, 2, 3. I had a bucket for the type of crust option. I have a bucket for the type of sauce option right here. And I have a bucket for the type of topping option. And what you need to ask yourself is, how many options do you have per bucket? Well, for the first bucket, the sausage or the crust, I had 2 options. And the second bucket, when I asked the type of sauce, I had 2 options again. And the third bucket said pepperoni, sausage, or cheese. Well, that gives me 3 options, and all you have to do is multiply the buckets. So what's 2 times 2 times 3? Well, 2 times 2 is 4 times 3, which is equal to 12. So there are 12 different options for Mr. Benson to choose from. And then you're going to see me use these buckets a lot when I talk about some of these theorems. I like these buckets a lot more than some of the equations they give to you. It helps you understand what's going on.